Hello everyone, welcome to our talk. As the title shows, my colleague Yiming Bo and I will share some of our findings and analyze some vulnerabilities. Also, we will show you how to achieve the one-click attacks. And before this talk, please allow me to introduce our lab. We are all from Oppo Secret Lab. Oppo Secret Lab was founded in March 2019 by Oppo Secret to protect our user data and infrastructure. And our lab is focused on Android web browser and IoT security. And we also reported multiple vulnerabilities to Google, Apple, and Apache. Okay, this is today's outlines. We will first give a brief introduction, then we will show you what is Google Instant App, Apple App Clips, and also their attack surface. And the third part is show you how to hijacking Google PW app. And the fourth part is how to achieve remote command execution on Quick App. And the last part is conclusions and takeaways. Okay, we first give a brief introduction. There are different kind of install-less apps like Apple App Clips, Google Instant App, Quick App, Google PWA. But they have all similar features. They are small in size and do not need to be installed, so they can be loaded quickly, and the user process is very similar to a normal app. On this slide, you can see there are many entries which is easy to discover, like QR code, web, NFC, App Center, but also there are other entries like message. Okay, please let my colleague Yiming to give you a detailed explanation on Instant App and App Clips.
Thanks. I'm going to start by showing Google Instant App. What is Google Instant App? It is an instant trial exploration. No need to download the app. In order to achieve the purpose of instant trials, Google has made a limit on the size of the instant app. The size of the application cannot exceed 15 MB. And Google Instant App is based on dynamic feature, so it can be faster updated. This is some entrance of Google Instant App. You can click Try Now on the app detail page in the Google Play Store, or click Instant Play on the game detail page in the Google Game Store. Or you can click the app design link anywhere, like message. And when you use Google to search the related keywords, you can click on the search result to open the Google Instant App. And this is the basic structure of Google Instant App. The first picture introduced the concept of APK splits. Google splits the application into a lot of models, and Android is able to download each of these features based on the accessor link, as long as there is at least one activity in the application that handles the URL. This means that you need which part of the feature, then dump this part of feature. So Google Instant App need to config deep link. Google Instant App supports two types of link, deep link and app link. App link is a kind of deep link, but they have some difference. Deep link supports any custom internet URL scheme, but app link only supports HTTP or HTTPS. Internet URL schema, deep link can use any internet action, but the app link only allows internet action of action view. Deep link can set any category, but app link only supports browsable and default. Deep link will not verify the link when click the link. but AppLink will go to your website for verification through HTTP protocol. When you click on a deep link, make sure choose for the user to select which app to open the link. But when you click on an app link, it will automatically jump to the specific application without the user choosing. Therefore, AppLink is recommended by users grab Google Instant App. In summary, AppLink has the following features: safer and strikes a more similar user experience, support Android Instant App instant loading technology, and can find your app from Google search. And this is the configuration example of AppLink defined in Android Manifest. You need to define an Android schema of HTTP or HTTPS and configure category as broadable. As we said before, AppLink needs to go to your website to verify the link. So you need to create a new field named accesslink.json in your website dictionary. In this field, you'll need to configure the package name and signature your specific for this AppLink jump. Google Instant App has some permission design. Instant App enable app bundles can only use few app permissions. Instant App can't interface with the install app unless one of the following conditions are satisfied, like visible to Instant App is true, or contain a category border internal filter, and Google Instant App will not support background service and notifications. Next, I will introduce Apple App Clips. Apple App Clips is not an iOS progressive web app. Actually, Apple Clips is an iOS app, but just a small part of your app. App Clips is easy to discover. App Clips has some entrance. Users can tap their iPhone on NFC tab that you place at a specific location to launch an app clip, even from the lock screen. You can also place QR code at a special location to let user launch an app clip by scanning the code with the barcode reader or the camera app. When your web page is configured with a small app bundle for app clips, user can just tap to open it from there. When you enable sharing with your app clip, users can send it via iMessage, and the person who receives it can open it right from message. When your app clips is assigned with a special location, you can register your app clips to appear on a place card in Maps, so the user can open it from there. And this is the basic structure of app clips. When you come in through the entrance just introduced, clips will go to the web service to verify the validity of the link. If the link is legal, then open the clip, and the clip can exchange data with the full app through the native SDK. And this is a dynamic app clips invocation flow. When you come in from the entrance just introduced, the system will determine whether the full app is completely installed. If it is installed, the complete application will be opened. If it is not installed, the app clips card will pop up. You can choose to click Install the full app on the app clip card. Then, we'll jump to the App Store to download it. You can also choose to try the app, and then App Clip will open. In App Clip also provide the function of downloading full app. After proof of inactivity, the system will automatically delete its app clip. And this is an app clip cannot share data with any other app except its full app. App clip and full app share data through group container. You can see it in the picture of this side. And this is the other permission design of app clips. Limit app triangle is always enabled in Apple app clips. Apple app clips cannot perform background activity. To protect user data, Apple app clip cannot access mounting and fitness data, app music, and media. Data from app like contacts, films, message, recommender, and photos. App clips cannot request continuous location access. Apple clips only support 8 hours notifications. Next, I will introduce a historic case study of Instant App. This is come from an ACM paper. It introduced a way of hijacking Instant App checks. When select a Yelp URL with smart text selection in an app, then select MIA. Android will recommend our MIA as a candidate for the processed URL. Then MIA correct provider data for user and hit itself by rebroadcasting the URL with an intent. Then click a Yelp URL in an app or Instant App. Now the Android will always use our MIA to open the URL without user's consent. This is because the Instant App is configured with deep link instead of app link. When the multi-clause application name starts with A, it will rank higher than Google chips from Android to select. So it is recommended to use app link for instant apps. You can see the correct configs in this feature. And we found that we can turn local attack into remote attack by Google Instant App. Under normal situation, if you want to attack the user's app, you need to trick the user to download and install the multi-clause application first, and then the multi-clause application send an intent to attack the user's app. Since the instant app does not need to be installed, so whether it can be possible to directly click on a multiple link. The multiple link will open the instant app, and then use the evil instant app to attack the user's app. Although Google Instant has a restriction on the communication between instant app and normal apps, but we found that this type attack is possible. And this is a normal local attack case. Then this is a case where the instant app was opened by clicking a multi-clause link and successfully attacked. We turned a local attack warranty into a remote one-click attack through the instant app. Okay, now I will hand it over to Ziyang to show you the next.
Thanks, Yimin. And I'm sure the third part, how to hijacking the Google PWA app. Google PW app is not like Instant App or App Clips. It's web app, but it's not traditional web app. PWA also aims to solve customer needs. It is fast and installable, reliable, and engaging. You can see the picture in the right panel. PWA is different with the traditional web app. And this is a basic PWA usage flow. If you log into a website before, traditionally, if you want to open it in app, you need install app and login again. But in PWA app, if we click install it, the PWA, you don't need to log in or authorization again. So there is a basic structure of PWA app. It consists with 3 parts: HTML connection with HTTPS. It means a secure page, and also a file manifest.json. It's same like Android manifest.timemail. Developers can define them, show them an icon in it. And also, we need a server worker. It will handle people install, promote, event, and offline fallback event. This is a typical PWA app workflow. It can cache resources and prefetch resources, so you can use it offline. Yes, it is different with traditional web app and all. Okay, I will give you an example case for Hijinking PWA app. You can see it in this picture. There is a PWA default install promote screen. Can we control it as we want? The answer is yes. You can see the picture on the slide. I have controlled the website domain. I type www.google.com on it. Would the victim trust it? Let's take a look about this POC code. As shown in this picture, we insert our CRF code into PWLM. And first, I don't realize that this is a bug. But when I open it in Android Chrome browser, the magic sense happened. Google doesn't handle new lines. We can control this dialog just using 2 simple symbols. After PWA app installed, can we hijink it again? The answer is yes. As this slide showing, an installed PWA app has low address bar and will show the app domain in app info wildgate. Can we overlay the information of app info wildgate or pull out the address bar, but show a wrong domain? How could we achieve this goal? We can use a special protocol blob. You can see it in this picture. If we create an open blob URL in PWA app window, the domain information in app info wildgate will be showing as blank. But until this step, victim still cannot trust this PWA app because he don't see any domain he can trust it. So we should give them the domain. And the POC code is very simple. We just set in document.title to a domain, like www.google.com. The address bar will be pulled out and show the web page title as domain. So victim would trust it after this step. Okay, let's go through our 4th part and analyze the Quick app and achieve the RCE on it. The QuickApp is funded by QuickApp Union Organization. Oppo, Vivo, Xiaomi, Huawei, all are included in this organization. And in the right panel, I gave a picture. It is a basic structure of QuickApp. It is running on QuickApp Engine, which is a native Android app. All these are running on the Android system. QuickApp Engine interacts with the application through the Chromium V8 engine, and also it can access hardware and sensors directly. Okay, in this picture, there is a landscape of QuickApp data transfer. QuickApp has a view layer and a logic layer. They are running on JavaScript engine, and the engine is responsible for processing data and storage data. Also, notification, process manager, status monitor is also included in engine. Also, acting as a middle between the hardware and the upper application page. Pank files and signature methods is the first step to develop a QuickApp. In order to secure this one, QuickApp has signature methods. SHA 256 is performed on each file in this RPK package. RPK package is the form of QuickApp. The file name and the corresponding biggest value are stored in hash.json. You can see it in this picture. After all files are packaged, size_zip function will be used to sign again. Function size_zip will use the certificate and the privacy key to sign each section of the zip file binaries and store it in binary. After package packed, this is the packed size_zip will be used to sign again. And function zip will use the sign again and to each section of the zip file binary. After package, this is the download and install flow. When a user click a hemp deep link or click it in QuickApp Store, client will send a request to remote server to validate the package name. And after it, client will receive the icon and RPK package resources from the server and store it to cache folder in the QuickApp engine privacy directories. But in the download process, its HTTP protocol and no verification will be processed, so we can make a man-in-the-middle attack. We can replace the real RPK package with our evil RPK package and execute alien commands, but it's just a fake command execution. We need the real RCE. Just one click. Could this come true? Yes. We will show how to achieve this. To achieve RCE on Android, we possibly can write an evil file to privacy directory and force the native app to load it. So we need to find the file access API. Fortunately, we found a lot of APIs supporting this situation, like download file system manager. After some research, we found download file API from remote server is the best choice to exploit. Download file API will fetch a file from remote server, HTTP or TPS are all supported, and write it to a tempo file path. So, can we perform the path traversal attack? In this picture, we write an evil so plugin into library main folder. And in this picture, we successfully write a eWorld plugin into privacy directory lib. Until this step, we just need to force the QuickApp engine to load this library. After some time trying, we did this goal. Lab imagine pipeline.so is successfully loaded. We can execute any commands. We use NC to get a remote shell, and on the tanker side, we get an interactive shell. You can see it in this picture. So this is a fortune to GitHub CE on QuickApp. When a victim click deep link or inadvertently touch the NFC tank, we can launch the QuickApp directly and then call the download file API to write a eWorld plugin to folder library main, then send an interactive shell to a tanker. And last, the main content of our talk is over. Here is the summary and takeaways. First is conclusions. We make 3 suggestions for developers. The first is secure the entries of installers apps would reduce the security risk effectively. And the second, monitor the legitimacy of links and files also helps reduce security risks. And the last one is developers need to pay more attention to the privacy APIs provided by the system, especially file operation APIs. And the last part is takeaways. In this talk, we provided the offensive landscape of installers apps. And we have shared some new attack vectors in Ample, AppClips, Google PW, Google Instant App, and QuickApp. And third, we should share you some suggestions for developers how to check if your application is also affected, and some mitigation techniques to against them. And this question and answer